Good afternoon and welcome to the Space Careers panel event. My name is Nevish and this is my co-host Reagan, and we're young STEM leaders from Dunfermline High School.
We are delighted to be joined by a panel of STEM ambassadors working in the space sector in Scotland. Each of the presenters will be invited to give a short presentation on their job and how it links to space, and then you, the audience, will be able to ask questions about their careers. Please use the Mentimeter chat using the QR code that will come up on screen in a second, and by either scanning the QR code or using the code which will come up on screen. We will be able to see your questions and pass them on to the STEM ambassadors after each one has given their presentation. Don't forget to say the name of the presenter that your question is for.
Yes, go.
The panelists we have joining us today are Shona Rapak, who is a research assistant at the University of Strathclyde, Mason Robbins, who is a manager for education programs, and Dr. Hina Khan, who is a stakeholder in engagement and a project manager for ESA, which is a European Space Agency. We'll now pass over to our first speaker, who is Shona Rapak, research assistant at the University of Strathclyde.
Brilliant. Thank you very much for the introduction. So, as I was introduced, I'm Shona. I'm currently studying at the University of Strathclyde doing my PhD. If you go to the next slide, please. So, before I started my PhD, I was still in the space industry, but I was looking at it from very different perspectives. Before, I was looking up from Earth to space. I studied astrophysics in my undergraduate. So that means that I was using telescopes and satellites to look at stars and planets and all this sort of fun stuff. But now I'm doing the complete opposite. So I'm looking down to Earth from space. So I'm using satellites to image what's happening on Earth, seeing what sort of activity there is, looking at the environment, and I'll go into more detail about what that entails. Can you go to the next slide, please? Great. So this may or may not be interesting for some people, but I'll just do a breakdown. So at school, I was really interested in sciences, and that's why I finished doing physics, maths, and chemistry, and then went on to study astrophysics in my undergraduate. But I found my real calling doing my master's, which was in satellite data for sustainable development at Strathclyde. And since then, I found that I love research so much. It's not for everybody, but I certainly loved it. So I stayed at the university to continue with my passions. Can you go to the next slide? Please? So my project that I'm looking at is by monitoring human rights violations with satellite data. So that means that I'm looking at any sort of atrocities that are happening on Earth and seeing if we can hold people accountable for what they're doing. There's different ways of doing it. You can look at, instances of war. You can look at companies and how they're affecting communities around them, that sort of thing. And what's amazing about it is that I'm looking at the world in different perspectives. I'm using my knowledge from astrophysics to really make a difference in the world if I can. And not only that, it's cutting edge science. It's very new field. And so maybe in the future, by the time you guys are thinking about university, that this would be something that you would love and it'd be a bit more developed. Next slide, please. To be a satellite imagery analyst, there's a few things that I'll briefly talk about. So, being interested. I said being good, but it's being interested in STEM subjects is the most important thing. It's all to do with maths and physics, and how all these sort of fun subjects interact with one another. During it, you need have sound coding ability, because we're using a lot of computers to analyze the data, and we're looking at all these maps and how they all interact with one another. And I think one of the most important things is you need to be creative and think outside the box, because you're looking at the problem from a new angle, and it might not be obvious at first, but once you look at different images and you can see how they interact, then you can paint a picture of what's happening on the ground. And next slide, please. So there's a lot of opportunities in this field. For me personally, I've stuck with university, but it's not for everybody. So there's different opportunities. You can go into government with this sort of skill set, or working, a private company. And as I pointed out, I've gone into academia. What I do have to say is an exciting new field. Scotland is very it's booming in this sort of field, so it's definitely a place to get involved. And I've put some links there for how you can get more interested in this field via ESA and NASA websites. And yeah, I'm looking forward to hearing from all of your questions and answering more. But this is just to briefly give you an overview of what this research entails. So thank you for listening.
Thank you for that excellent presentation. Now we'll be moving on to our second speaker, who is Mason Robbins, who works as a manager for education programs.
Yeah, hi everyone. So yeah, that was a hard one to follow up. Great last presentation. But who I am, where I'm from, I'm Mason Robbins. As you can tell, I'm originally from the States, but I've been here in Scotland about 12 years now, and up in Untitled for about the last year. I've got a PhD in Science, Technology, Innovation Studies from the University of Edinburgh, but that's not necessarily where I came from. I actually have been working in the sports industry, where I was helping with start the FC Barcelona Innovation Hub with the football club in Spain the last few years, and then did an industry change, and now I'm back in space. Actually have my old space camp old flight suit on. It actually fits, and it's about 21 years old, so everyone makes fun of me that how can I still wear something that's that old, but hey, I guess if you work hard, you try, you never know where you might end up. But my background, actually, I studied quantum mechanics and physics when I was really young. It was really focused on that area. But then when I went for my undergraduate degree, I did diplomacy, international relations, and worked for the UN for a little bit, even before I got into sports business. But then I'm one of those crazy people who has a few masters in a few different areas, but then landed with one in astrophysics and just kind of kept pushing that aspect of it. So here at Saxavord, I'm kind of in charge of everything: education, innovation, skills, and beyond. But it's always that kind of balance between academia and industry. And I think there's always, anytime you have that opportunity to do a work placement or get out in the community or cross over your academic interests and what you want to do, that just broadens that spectrum. Whereas I like to say is like, we're in this new space. So a lot of people talk about new space, and in new space, it's not about being the ex-military fighter pilot, but it's about doing what you love with whom you love and helping others. And if you do that and just apply yourself to whatever subject, then you have a place in space. I like to tell students that it took 450,000 people to put 3 people on the moon under Apollo, and we're already well over 1 million people working together, including myself, on the Artemis project to return not only men, but also women and people of color of various backgrounds onto the moon and Mars and beyond. So it takes a whole team to get there. So you could be whatever you want to be, as long as you apply yourself and you're the best at that. You're going to have that opportunity if you want to live, work, and play in space. That will be there. And I'm a mediocre lacrosse athlete. I actually am one of the captains of the Scottish national lacrosse team and play on the side. And then I have the most northern husky in the United Kingdom who stays with me up in Shetland. Her name's Isla. She's a little brown husky, and we even have protective equipment for her if she's around site and needs to be seen. So it's kind of fun. So why do I do this? Why do I love it? Why is space education so fascinating? It's about inspiring the future STEAM leaders of Shetland, UK, and beyond. I mean, the cool thing about Shetland, and it was reaffirmed in a conversation that even Dr. Khan was on earlier today from Spire, who you'll hear from next, is Scotland produces more satellites than anywhere else in the world outside of Southern California. And we process more data than almost anywhere else in the world, or comparable to a lot of places in the world. So we have that downstream and upstream. Spaceports and everything in the middle is now taking all these great Scottish companies and UK companies and giving them an opportunity to then take our ideas and put them in the future. And again, I love STEAM because I think arts is a huge proponent of and component of where we're going with space. You need to be able to tell those stories. I mean, I've worked with data sets that I've spent a lot of time on trying to wrap my mind around. And then you take someone who's been playing, I don't know, fiddle, violin since they were a little kid, and then they look at the data set and they'll see it completely different through a different kind of eyes. And so we're recognizing those perspectives in the industry and how important it is to have those backgrounds. So if you want to move on. Yeah, so why space? I went over a lot of this. Sorry, I got ahead of myself. But it's just that what I really, in our whole mission here at Saxford, and my mission of what I do, is I want to let you know that no matter how young you are, you have permission to dream and work towards living, working, and playing in space, because space is going to be for all. And we want to have those opportunities for kids and young students and everyone, that if you want to go to space, you want to do space, it's there for you. It's for everyone. Just imagine it. But you got to think outside the box. You have to have that quantum thinking. You can't just think that linear old space, old school mentality of space is for somewhere else. No, you got to think that space could be a part. Now, what can I do to contribute to that? So that's kind of where we're at and what we're thinking about, why it's there and why that's important. So I guess the last, and this kind of takes me to my last slide, is so why Shetland and why is it important and what does this do? Well, Shetland, we're as far north as you can get in the UK. There's nothing north of us. So it's location, location, location for spaceport. But just because you might be in charge of education, or you might be in charge of range, or you might be in charge of business partnerships, or you might do different things, there's all sorts of overlapping things you might do in a spaceport. I like to laugh that this time last year, I was lecturing at the University of Edinburgh, teaching international political economy. And then suddenly now here I'm wearing PPE, protective equipment, and steel-toed boots, walking through a mud pit to launch a rocket. And it's everything in between. So I have a few pictures of here that just kind of show the various stages. We have a huge Viking culture here, and this gets back to the arts aspect of the storytelling and the oral tradition and why that's important. But also, we like to say it's from the longship to the starship, and that's where we are now, and that's what new space is getting towards. So with that, I'll kind of leave it there for questions, or else I get way too excited and talk to you all for the next hour and a half. And I'm sure you'll want a break before then. So I'll just hand it back over to our moderators. And thank you so much for having me on.
That was so interesting. Thank you for that presentation. Finally, we have our last speaker, who is Dr. Hina Khan, who is a stakeholder in engagement and a project manager for ESA, the European Space Agency.
Thank you very much. So yeah, thank you very much for inviting me here. I'll just make a slight amendment. So I work for a company called Spire, which is a small data analytics company. We build small satellites, but I have a number of different hats, so it's fine. I've worked at the European Space Agency as well, but I wanted to take you just a very quick whistle-top tour on my journey to get to here today and how it's kind of changed over the years. So if you just go on to the next slide. So apologies if people who we were on a call this morning and some of the slides are similar. When I go into schools and I talk about space and I talk about all the different things that you can do with space, I always like to start with a question of what does space mean to you? And then we always get a whole variety of different things, but generally it's things to do with rockets, astronauts, space stations, planets, extragalactic things, galaxies, quasars, and sometimes our sun, but not always. And if you move on to the next slide, and really what does it actually mean? Well, it does mean all of those things, and I think those things are very important, but it also means how we understand and monitor the things that are happening on our own planet. How do we move things around our planet to make sure that we have the food in our shelves and the clothes that we wear and the cars that we drive, and that kind of logistics. And also, how we monitor our Earth and look for things from space, looking down to understand our world better, looking at weather patterns, looking at transport networks, and also how things are growing, and how agriculture is used. And space is used in all of these different things. And it's important to remember that whilst there is that kind of outside of our world environment and space and exploration, there's also a very practical aspect to what we do in the space segment as well. If you go on to the next slide. And that really is where, we have our everyday usage of space. So we all know that, we all have our Sky TV at home and we can watch television, and, we use our mobile phones for navigation and making sure that we can get to A to B in the time that we need. But we also use space in other ways, when we use cash machines, the transfer of information can be done and is done in some aspects using satellite networks. When we do construction, we have to think about the area within which we are building bridges and houses, and is that land able to support and sustain those sorts of structures? And so we use space to help us understand that. When we're growing our crops and farmers are trying to understand how can they meet the demands of your Tesco's and your Asda's and your Lidl to make sure they have enough crops to fulfill what people want to buy, we have to make sure that we can plant accordingly and that the land that we are irrigating and growing crops on is able to provide that. And these things are done from space data and applications from space. If you go on to the next slide. And also, we live in a world which is forever changing, and as many people we've talked to so far, sustainability and the environment are huge big things, and arguably significantly more important than some of the other aspects that we might use space for. But space is involved in all of these areas, whether you're looking at deforestation and volcanic gases, all the way through to trying to detect wildfires. These are hugely global challenges, and we need to collect that data in a way which allows us to make the decisions that we need to be able to stop these things from happening. If you just go on to the next slide. So just to kind of bring it back to where I come from, as I say, I work for a company called Spire Global, but I didn't start my life thinking I'm going to go and work for a space company. I was just really excited and interested in things to do with space, very much on I like to look up in the stars and I want to know what's going on outside of my own back door. And so I followed a passion in physics and astronomy and went on and did a degree in space science. And that little animation you can see with the green splurges is work that I did whilst I was at the NASA Goddard Space Flight Center in Washington, where I was looking at how the sun, which is emitting a lot of radiation and a lot of plasma, how that impacts our kind of Earth, and then creates things like the Northern Lights and other interesting features that affect us on the ground as well as in space. And I spent a long time just in research, trying to understand how our world works. And that's all very well and good, and there's absolutely amazing science happening there. But I became a little bit, I wanted something more. I wanted to do something which was arguably more valuable, but perhaps just more relevant. You know, how does what I have been studying all these years actually make a difference in all the ways that I've just talked about? And so I was able to come back to Scotland over after a number of years and start to look at how things were changing. Industry companies were coming to Scotland to set up their space business. Now, what does it mean to be a space business? It means you're either building things that go into space, which is something that Spire does, using information that you get from space, which is also something that Spire does when we look at data analytics, but or using things which can be applied in a space environment. And so it's lots of different things. And I became very interested in that aspect, and so was able to really look at how the space industry within Scotland was changing and also growing. And so I did a number of different things to support that, to build the ecosystem, which is just a fancy way of saying all the different bits and pieces that were interested in doing good things with space, and then join that together so that we could actually drive something of value here in Scotland. And so today I work for a company that brings all that together, and we do, you know, Spire has launched over 150 satellites from Glasgow, built in Glasgow and launched from various different places, and we're able to use that data in a good way. So that's a really quick, I think that's me done. Is there one more? I think one more on. No, I think I'm done. Thank you very much, and I look forward to questions in a second.
Thank you so much for your amazing presentation. It's really amazing to see what careers are available within Scotland in the space sector. Now it's time for questions from the audience. Remember to say who your question is for and what school you are from.
First off, we have, what subjects would be best to study in school for a career in space? And this question is directed to Mason.
Yeah, I honestly, I think it kind of goes back to just, I mean, of course, the STEM subjects are great if you want to go into engineering or you want to figure out some of those kind of more technical issues like we were talking about. But at the end of the day, new space is going to have so many different opportunities. I mean, when you think about we're going to put permanent civilizations on the moon and then eventually Mars, you're going to need plumbers, you're going to need farmers or crofters, you're going to need various roles within just what we take for granted every day. So again, just as long as you're applying yourself and you're going and you're doing what you love, then it really is less important about specific subjects, but just trying to be the best that you can be within that subject.
Thank you. The next question is for Shona. What careers in the space sector will be available in Scotland within the next 10 years?
Wow, that's a really difficult question. I think I'll go along the same lines that Mason's just talked about there. I think, you know, we're right at the edge of what we can do with what people think to be in space. You know, when I started my career many years ago, there really was only one avenue that you could go down, and that was you become an academic and you sit within a university, and really that's what everybody told me, and I was like, okay, I'll have a think about that. And so, you know, for many years that's what I did. But actually we're in a completely different environment today, not least because of technology, but also because of people's want to be able to do something which is of value. And I think space gives us an amazing platform from which you can do that. You know, Mason touched on it, you know, STEAM, I'm a big believer in STEAM as well. So STEAM in terms of science, technology, alongside the arts, because I think we need to be able to, you know, showcase and talk about what we do in space. And, you know, space has a massive problem in being able to promote itself. And part of that is because we're all, you know, well, not all of us, but some of us are very, you know, technically driven and not naturally able to talk openly, you know, creatively about what the things that we do. So, you know, space has become a business environment, not to make it too corporate, but within a business, you have all different functions. You know, you have the drier subjects on the finance side and the HR and the things that people don't like to talk about, but you also have the creative side, the storytelling, the marketing, you know, the PR, and, you know, all of these things that want to be done. And then when you think beyond that, you know, as Mason said, you know, we're not talking about things which are 10, 50, 20, 30, 100 years away. We're talking within absolutely your lifetime, maybe within mine, hopefully, within the next 10, 20 years, there will be habitats that we are starting to develop in other planets and our moon. That's already in the pipeline. These things are already happening. And so when you start to think about that, well, how are you going to get there? How are you going to live there? What are you going to eat? We've all seen The Martian. He grew potatoes. We still need to find a way of doing that. And if not on another planet, then even in our own world, how do we make sure that the planet that we live on is still in a state that allows us to progress from? So I think, I would flip the question back is, I'd be very interested to find a job that wasn't relevant within the space sector in 10 years. I think any career that you choose can be applied within that environment. So not maybe the answer you're looking for, but definitely something I hope is caused a little bit of controversy. So.
Thank you very much. The next question is for Shona. Where in Scotland are the biggest bases for space careers?
Oh, that's a really good question. We're not in Scotland, is there a base in space careers? Because at the moment, space is dominating most areas in Scotland. I mean, I'm biased. I'm based in Glasgow. Glasgow's got a massive hub for engineering, manufacturing of satellites and all this fun stuff. But in Edinburgh, they're dealing with the downstream part, which is all about how we're interpreting the data that we're collecting, how we, the software sort of side of it. And then we've got a perfect example, Mason's being all the way up in Shetland. So we're kind of spreading across Scotland. And even if there's areas in Scotland that don't have a direct link to space, there's always, as Hina was saying, there's always going to be that sort of the indirect link to it. It could be, manufacturing materials for, next launch, that sort of thing. So I mean, I'm biased, I'm going to say the Central Belt, but at the same time, I don't think we can limit ourselves to just that one area for Scotland, because we're dominating, we're exploding in terms of creativity in the country, and we're definitely leading in terms of what we can do in space and how we can achieve it.
Thank you. The next question is for whoever it's most suited for. What would happen to the planets if the sun never existed?
I'll start off, but I have a feeling Mason might have a question. I might have a take on this as well. I mean, I think from my science background, I think, the sun is integral to life on our planet, as well as the formation of the solar system. And if you look at kind of the dynamics on how solar systems are formed, not just in our solar system, but all solar systems, and you look at the kind of astrophysics of that, you need the gravitational effect that the sun provides and the magnetic environment, as well as the heat and the energy and the sources of energy that it produces, to be able to create both life on our planet, but also the formation of the planets. The sun is a massive magnetic structure, and that allows material and plasma to then spin around, and then that eventually coalesces and then creates your planet, from which you then get atmospheres and various different things. So a star is in our sun is no different from the millions and hundreds of millions of stars across galaxies in the universe. It's not unique, and it's not anything special per se, other than obviously we are life on a planet. But that's why the astronomy part of space is still so important, because exoplanets are being, we do know that there are other planets that are around other star systems and other formations, and could they be sustaining life? Possibly, maybe. Who's to say not? I'm very much of the mind, as I find it very, very challenging to think that we are the only sentient being in our entire universe. I find that a little bit a little bit egotistical for us to think that we are singular in this universe. But then there has to be the right mix of things that happen. So I think the star is integral to everything that we have and everything that we do, and it would be a very dark place if there was no sun, if anything at all.
I won't add much to that, but it's in the same way Jupiter is just as important as the sun, because it helps, the gravitational pull of Jupiter helps balance that Goldilocks zone that has this prime opportunity for gravity to hold and work, and temperature and everything, that it's just this great mix that we're here together. So without the sun, we wouldn't have, basically the planet wouldn't even exist because there would be nothing holding it there. So yeah.
Thank you. Shona, do you have anything to add?
No, I think they perfectly summarized it, to be honest. Yeah, I think that was bang on explanation. Not that I'm an expert in that sort of thing. They're definitely more experts, but yeah, we definitely wouldn't be existing if we didn't have the sun. It's very important.
Thank you very much. This question is for all panelists. What part of space interests you the most?
I can start that. Or yeah, just real quick, because I'm interested to hear what everyone else has to say. Is I love the concept that if you can solve for space, you can solve for Earth, and a lot of the challenges that we have faced or we're overcoming here on Earth, if you can find a solution in space, a lot of times that will cross over to how we can either grow food more effectively to feed and nourish people with less space, because space on Earth is a premium. You're not going to make more land. Or if it's technology, I mean, the whole concept of having a camera on a chip in a phone is something out of the space program, or coming up with solar energy or how we can better use solar energy. So that's what gets me out of bed or excites me, is that whole concept that as we engage space more, we learn more about space, an environment that wants to kill us, we are able to overcome a lot of the challenges or understand more of the challenges here on Earth than we ever thought before. So yeah, that's in a nutshell.
I could go next. It kind of feeds on from yours, Mason, that something that I love about space is just being able to, on a really dark, clear night, just looking up and realizing that there's more to life than, our small problems. It's infinite up there, and I feel like there's some pretty angry people in the world. We all get angry, we all get upset sometimes, but it's just such a awesome thing to appreciate. And so just taking the time, I would say that there's a bit of reflection coming, like whenever you need a bit of downtime, just looking up at space and just seeing this amazing sky of stars and planets and all that stuff. And that gets me excited every time I go out with my telescope. That's what got me into space and got me excited about science and everything, was just going with my telescope outside and seeing what cool things you can look at.
Yeah, I'm not sure I'm going to add much more to that. It was exactly that thing. I think just they talk about, when the first pictures from the moon came back and you saw that pale blue dot, it just puts it all in perspective. It is the vastness that space has to offer, and that we are on this very precious and very fragile environment that we all have to take care of. And so what excites me about space is that, how do we use exactly what Mason says? How do we use what we gain and understand from space to make our world a much better place to live on? We don't have anywhere else to go until we work out a way of living on another planet, but we've got to make the most of what we have here. And how do we use the technologies that we've developed over the decades to make that a better place, and just keep a hold of what we have of value here. So.
Thank you. This next question is directed to Mason. Why does it take so many people to get someone on the moon?
It's just the whole process that you got to work together as a collaborative manner, from the people writing the code to building the different parts. I mean, if you look at Artemis alone, each section of the SLS rocket in itself is being developed by different companies and different partners in different areas. So it's just the vast number of minds that need to be put around to do something like that. So yeah, it's part of that team effort.
Thank you very much. This question is from Torton's Primary. What has been the hardest problem to get around? How about we start off with Shona?
Hardest problem to get around was, for me, it wasn't necessarily to do with the actual subjects that I was studying. It was just trying to convince myself that I was allowed to be there. Like, I had a place there. I was worthy of getting to study these interesting subjects, believing in myself. It's really hard when you're being bogged down with numbers all day, or you might have doubt and everything like that. And I never came naturally to STEM. I had to work really hard, and sometimes it felt like I couldn't get through it, but I did in the end, and I still am every day. So I think the hardest part is just, convincing myself that I am good enough for it.
Would anyone like to add anything else?
I think that's a good answer, I think, by Shona there, I think.
Yeah, definitely.
Okay, the next question is for Dr. Hina. How would you monitor wildlife with satellites?
So that's interesting. I think there may have been a perhaps maybe I wasn't clear enough. I was talking about wildfires, but you can also monitor wildlife from space, so it's a little bit more challenging. Let me talk about wildfires first of all. So wildfires from space, you measure basically heat and emissions that you can see sparking off in various different areas, and you use a technique called infrared imaging. So you're looking at within the spectrum and within the kind of environment of waves that we have in our universe. There's a particular element that measures heat. Basically, it's what we have infrared cameras for, and you can measure those from space, and wherever you are, you can then pinpoint exactly where that location is, and you can detect wildfires from there. In wildlife, what we done, actually, I worked on a project where we were looking across the west coast of Scotland. We were looking at jellyfish blooms, and that's where across the west coast of Scotland, particularly, you get these massive big shoals of moon jellyfish, which are fairly large features, and they're very kind of close to the surface of the water. And what they do is they discolor the surface of the water. It's a slightly different visual aspect, as well as the kind of the way the satellite data can penetrate and bounce off the very top layer of the ocean. And so because these shoals of jellyfish are quite large, you can actually see it from space, both in the imagery as well as using other radar techniques. And from that, you can then look at the motion of those things. And why are jellyfish important to know where they're going? They actually cause hazards to fisheries. So salmon farming and other things, they can actually cause whole salmon farms to be completely destroyed because these jellyfish can be damaging for these environments. And so we can monitor that, and then through looking at different data sets, see how these areas are moving through the oceans with weather and wind and different things, ocean speeds. You can then predict when and where they may hit a particular fish farm, and you can send them alerts to say, actually, you need to do something about this because jellyfish are coming or whatever. You can do that. So there's lots of different ways, and we work with marine biologists and other scientists to understand these things in a better way. And space data is just another element that you add into that discussion. So yeah, lots of exciting things with space to do on that.
Thank you. This next question is for Mason. How would you build on planets with low gravity?
Oh, that's an engineering question, and I'm not an engineer. But it would be the same way if like you're just trying to anchor something down. I mean, when you're working with 0G or low G, it's always that force reaction type of thing. So you want to make sure that you're secure in whatever whether it's a HAB or if it's a craft landing, and then you just have to account for the different gravitational pull, whether that's if you bounce a ball and it's going up, or when they hit golf balls on the moon. I'm sure there's some golf balls that might still be orbiting around the moon if they hit them hard enough and high enough. So it becomes just a mathematical equation, I guess, to
I'll kind of help you out, Mason, a little bit. So I think, no, absolutely. I think it's a really interesting question. But that's why the tests and experiments they do on the space station are so important, because that is in a low gravity, a low gravity environment, a low G environment, because the space station is not in what you may think outer space. It's not way beyond the realms of the atmosphere. It sits at around kind of 300, 400 kilometers. And that's probably a kind of, 2 or 3 G environment in terms of what the gravitational effects are there. And so it's people who are floating, you see the astronauts kind of floating, but they can still do things and they can still maneuver. And so we do a lot of experiments in those environments to exactly understand how does a low G environment affect various different things if we were to go to different planets and then do construction on that. But you're right, it's an engineering problem, and it can be solved, and there's a lot of testing on that that's being done on the ground and in the space station, which is why experiments there are so important.
What Dr. Khan said.
Thank you so much. The next question is for Shona. Why did you decide to go to the job that you are doing?
That's a great question. That it links back to my second slide of my presentation where I had the picture of an image of space. I think it was Orion constellation, and then I had a picture of a satellite taking an image of, I think it was Scotland. I can't remember exactly, but essentially the skills that I gained from astrophysics are very applicable to different jobs, and I loved studying astrophysics, but I found that it wasn't for me. I saw what was happening around the world. Climate change is a real thing. There's all these inequalities happening, and I wanted to use the skills I gained from my undergraduate into another job. And I found that the best way was by analyzing satellite data, because it's the same way it's just a different way of looking at the same problem. I'm using images taken of Earth and seeing how we can infer certain information from it and how we can act upon it. It's not just about collecting the data, it's how we can act upon the images that data that we collect. So essentially, yeah, I'm basically doing the same job, just different problem at the end of the day.
Thank you so much for that. This question is for Dr. Hina, and it's by Torfin's Primary School. Does space have an impact on global warming?
Oh, that's an interesting question. Does it have an impact on global warming? I think, when you're doing things like manufacturing and building and traveling around and business activity in general, then we all have an impact. I don't think any industry is can state that they're not making some level of impact. I think what we have to understand, though, we have to understand our own impact, and there's a lot of work being done here in Scotland to look at the sustainability of the space sector. In fact, I think Scotland is one of the only spacefaring nations that's actually published a strategy on a roadmap on what does it mean to be sustainable within the sector. And that's actually the sector inwardly looking at itself and saying, what do I as a space company do, and how do I make that more sustainable? And that's a really important thing to measure and to understand, because whilst we can use and talk about space to help solve these problems, we also need to understand our own impact on that and try and minimize that as much as possible. Now, you can argue the case that we're using sustainable rocket fuels, which we absolutely are. We're making sure that our environment is being maintained by reducing the impact that we have on it. We're building small satellites, and so they're relatively easier to get rid of, and they're not causing a huge amount of harm within the wider scale of things as relative to some other industries. But you can't say there's no impact, and so it's important to balance that. And I think space has a huge amount to offer in terms of helping to solve the climate problem, as well as but you can't say that you need to understand how you also are impacting it. So it's an important thing, and Scotland is leading on some of those questions themselves.
Thank you so much. Shona, do you have anything to add?
No, I think Dr. Hina is summing it up perfectly, to be honest. I think it's all about the actions. Space is there. Hasn't changed. It's how we're using the environment that is changing, and we're using it. It's accelerating. That use of it is accelerating with every year. But as long as there's considerations taken into account in the industry, like Dr. Hina said, then it makes everything a lot better for the environment and for ourselves as well.
Thank you so much. The next question is for Mason. Do you think humans will ever try to get rid of space junk?
Yeah, that's something that a lot of us are actively thinking about and working on. And even Strathclyde University has got a really good research on looking at space junk and tracking space junk. And it's something that I know as a spaceport with working with rocket companies that if we can come up with some sort of plan to either limit or even remove space junk during some of our operations, that's something we're always open to. But it's going to take a lot of people thinking about this and really wanting to be a part of finding a solution. But I think a lot of it just starts at the conversation, like even at this level, like we can do our best to try to minimize it now, but it's not something that's going to go away overnight. So we need to think about how do we not increase it in the same sense too. So yeah, that's a tough one.
Thank you. This question is by Newfield Primary School. How is space changing? This could be for Shona.
Space, the environment is not changing that I know of. I mean, the universe is expanding. It constantly is expanding. I think it's actually accelerating. So that sort of environment is changing, but it doesn't affect our day-to-day lives. In terms of the space industry, so that's the jobs and the buildings or to accommodate all this, the rockets, that sort of industry, it's vastly changing. It's changing from when I started uni to when Mason and Hina started, when they started their careers, you know, and when you guys, if you guys ever want to go into the space industry, it will be completely different then. I think it's going in a good trajectory in the sense that I think people are thinking outside the box and they're trying to be a bit more aware of other impacts that they might have, whether it's on the environment or it's on people's communities and that sort of thing. So it's definitely going in a positive direction, and it's going very in an exciting way, that's for sure.
Thank you so much. And thank you to everyone for submitting all their good questions. We're trying to get through them all. The next question is for Dr. Khan. How many years at university to get into something like NASA?
Think. So obviously I went through a pathway which allowed me to get into that position. You know, I did my undergraduate degree in physics and astronomy, and then I went on and did my PhD in space science at Leicester University. And after that, I kind of stayed within a research environment. So after you've done your PhD, you can, you know, get a job within the university and just continue researching in various different areas. For me, it was space science, so that interaction between the sun and the earth. And space is a global collaborative environment. There's no boundaries in space, both physically or metaphorically. And so everybody is, particularly within a university and research environment, everybody is very, you know, collaborative. It means we share a lot of things. So we share ideas, we share, you know, programs, we share activities, we share data, you know, everything is shared within that community. And so, you know, I was having discussions with people at NASA already just on my research program because they were doing work which was interesting, it related to my work. And so there were all these conversations that were already there. And so there was, at the time that I went to NASA, there was actually a program that you could access from the UK that allowed you to go and do a couple of years, almost like an exchange program where you would go and you could work at an institute like NASA, work with their scientists for a few years and learn things, and then bring your ideas or research or whatever back to the UK. Some people came back like I did, other people stayed and built a career at NASA. So it wasn't something that was unusual. It was still challenging to get to. You needed to make the right connections, but within that environment, it was an easier thing to do because we already had those links. And like I say, it's not like I mean, obviously it's a job, but within research, it's more collaborative. So it's more of a sharing of knowledge. And that's true across a lot of different, it's not unique to space. I think in any research environment, I think that's also the case. So.
Thank you for that. Sorry, we've only got time for a few more questions. Mason, can we see your spacesuit?
So real quick on that last one too, because I was just doing a project with them. There's opportunities. So I've been a part of NASA Social, which people as young as 18 can go over and do the partnership with NASA. around a launch and get some behind the scenes. And then there's opportunities with internships, and their internship is a really great way to get involved that even wasn't available when I was doing my undergrad. So a lot of that's changed soon. So really, there's a lot more opportunity, and there's growing opportunity now that SpaceX and Blue Origin and then ESA and other programs. So if that's something you really want to work with a space organization like NASA, then I would just start researching what kind of other opportunities and just starting to get your foot in that door. So by the time you finish your university, you already have some of those connections that then could lead towards further research opportunities or whatnot. So yeah, so flight suit, still got it, still working. I was really lucky when I was way back that I was tall, and so they kind of made a one size fits all. So now that I'm a little bit bigger, it still fits height wise, and I've actually had to tighten it. But yeah, it's honestly just going back. It's just start building those connections as early. I mean, even now there's programs with ambassadors like what Dr. Hina's doing with ESA. Just building those relationships will set you up that as soon as you are into your university, you can have those access opportunities.
Thank you so much for showing us that. The last question is, what is beyond our universe? And we'll start with Shona.
Oh, that's an easy one to finish on. What's beyond our universe? Essentially, I mean, I could be wrong, but I believe the latest thing is that they still don't know. I could be wrong, but essentially the universe is infinite, so we cannot reach that point of going beyond it. But I understand that I haven't been actually researching. I haven't studied this in a while, so if Hina or Mason have a more eloquent way of putting that'd be gratefully helpful.
I'll see if I can help you out a little bit. So I think, yeah, I mean, what's beyond the universe? This has been a question which has been, talked about for many, many decades and will continue to be. But we, as our understanding grows and our technology develops, the launch of the James Webb Space Telescope is phenomenal. And, that's really looking to help answer some of these questions, or at least give us a little bit more information to help answer these questions. James Webb Telescope has been designed over decades, and even when I was back as a student, it was in the mix. And so to see that launch and to see the images which are coming back, which really are probing the very edges of our universe. And remember, this is light which is coming from the very edges of our universe. And if you're measuring light which is very, very faint, that translates to a distance. Hence why you can see that the universe is 13.7 billion years old or whatever it is. And as we probe the universe in that way, it lets us see what it was like at that time. And so the theories are always around the expanding universe, and from maybe a point of origin, maybe not, but that expansion of the universe is something we can absolutely measure. But I don't know if it does it affect us whether the universe is expanding or not. I think we need to understand how we fit in that framework and what it means for us, and how we value what we have here, and how we make sure that is there for generations and the next kind of millennia to come. And so just keeping that in mind. But as our technology grows, our understanding grows, and that's where space science, extragalactic and extra astrophysics becomes really, really important to keep that understanding going.
So I guess from my kind of metaphysics background, which is kind of bringing social science understanding to hard science, it's going to date myself, but beyond our universe is the number 42. Which is basically looking at what's life, the universe, and everything. What does it mean? And I think I would have to lean on kind of the thoughts of like Galileo and standing on the shoulders of giants, that what's beyond our universe is our imagination. And I know that's not a hard science answer, but it's also, we don't know. And that's what makes it amazing. Because if you look at one characteristic that's across all of us on the panel, our moderators and beyond, people working in NASA, ESA and beyond, is we all have a natural curiosity. of the world and space, and that's what's beyond our universe, is to find out what that is. So how long is a piece of string? It's as deep as the ocean. How far is space, and how do we get there? That's a question for not only us to try to work on, but to give you all the platform that you can start discussing and figuring that out. And then once you've been to Mars, where next, and all that kind of stuff. So yeah, not to bring it around in a completely different kind of social science direction, but to look at it's kind of what we want it to be, or what we hope it would be, but it also is that unknown that drives us to try to figure it out as well. So
I think I want to say something that doesn't sound like to act like talk on that. What Mason was saying is that is the reason why we need more than just people interested in STEM and space. Is we need people to push our questioning about, what's beyond the universe, whether something's ethically right or wrong. All these like social scientists, artists, it's not just a science field, it's across many disciplines and many interests. So I think that question, even though it might not end up the answer that you wanted, it's demonstrating that space is for everybody, essentially.
Thank you for the answers. Unfortunately, that's all the questions we have time for today. Thank you so much for joining us today, and thank you for all the speakers that attended. If you want to know more about careers in space, join into more sessions during Space Week. Thank you.